start with countable sets, so a set that has the same size as the natural numbers. So one way in which it can be ordered is like the natural numbers are ordered. So like that. But there is a different shape that an ordering of a set of that size could take. For example, you could have countably many items arranged this way, and then an extra thing at the end. So notice that these two sets, so the one that's just like that, and the one that has the extra thing at the end, have exactly the same size. They can put in 1-1 correspondence with one another. But the ways in which they are arranged are different. Can anyone give me a different way of arranging a countable set? One very different from any of the other ones I've written down?
1, 1, dot, 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 and then do another 1, 1, 1, dot, dot, dot.
Yes, nice. Very nice. Very nice. Or indeed 3 or 4, or as many as there are natural numbers. So this kind of ordering, the usual ordering of the natural numbers is called an omega sequence. So omega is the last letter of the Greek alphabet. So that's an omega sequence, and what philosophers call a reverse omega sequence is that kind of ordering, but in reverse. So you have countably many things to the left, and then a last thing right there. So that's a reverse. In fact, you can think of the integers, so both positive and negative, as a result of putting together a reverse omega sequence for the negative integers and a regular omega sequence for the non-negative integers. There are zillions of little puzzles that philosophers like, which are based on omega sequences. So they're all of the form, start with an omega sequence or a reverse omega sequence of people or steps or something, and then add in some details, and then look at what happens. So we're going to just talk about a bunch of those. Today's session will be the closest to fun that philosophy can be. So philosophers have party tricks, and these are them. And one reason I think it's fun is that I'm going to talk about a bunch of puzzles, and for some, all philosophers agree about what the solution is. But for others, they don't. So like, I'm genuinely interested in seeing what you guys think and like what seems possible to you guys and what doesn't seem possible. And another reason I want to talk about all these things is that one of my old mentors is basically the most famous living creator of one of these omega sequence puzzles. So he's the guy who came up with Yablo's paradox. So I'll briefly tell you about Yablo's paradox today, and then on Wednesday, Yablo himself will come talk to you guys. And he sent me his notes over the weekend, and they're awesome. Like it'll be so good. So also, I want to prepare you for his session because like I don't want you to miss one bit of it.